Welcome to another session. In previous sessions, we finished velocity analysis by using relative velocity method. In this session, we are going to start velocity analysis using instantaneous center method. As far as gate is concerned, IC method is more important than relative velocity method. Most of the times, gate questions are coming from instantaneous center method rather than relative velocity method, right? If anybody is preparing for both gate and IES, both methods are important. If you are preparing only for gate, so this method is more important than relative velocity method. Concentrate more on instantaneous center method, okay? So first I am going to define instantaneous center for a single kinematic link. Thereafter, I am going to define instantaneous center for a pair of kinematic links. Thereafter, we try to understand how to find unknown velocities by using this method in a mechanism, right? So first, all of you may write instantaneous center of a single kinematic link. Instantaneous center of a single kinematic link. Instantaneous center of a single kinematic link. A single kinematic link. Single kinematic link. This link is having translatory motion at the same time rotary motion also, right? So here I have drawn a kinematic link. This link is having translatory motion and rotary motion also. Both motions are present with this link, right? This is beginning of this cycle. In a small interval of time, this link may move to a new location like this, right? So this is location and orientation of link in a small interval of time. Okay, this is beginning orientation, beginning location. As it is translating towards right, it moves towards right. At the same time, it is also rotating, man. Okay, it is translating as well as rotating. So this is the location and orientation of link in a small interval of time. Then join these two. Join A and A dash. Join B and B dash. Then you may draw a perpendicular bisector to A dash and B dash. So these two are intersecting at one point. You may call this point as I1. Okay? You may call this point as I1. During next instant, this link may move to another position and location, right? Maybe this is the location and position of link after next instant. I may call this point as A double dash. I may call this as A triple dash. Okay? Now join again these two and these two, right? Again, you may draw perpendicular bisectors to both the A dash, A double dash and B dash, B double dash, right? So I am joining perpendicular bisectors to both and I am getting another point. I may call this point as I2. During next instant, the link will be somewhere here. I may call this point as A triple dash and B triple dash. Again, you may join A double dash, A triple dash, B double dash, B triple dash. Then again, you may draw perpendicular bisectors to this A double dash, A triple dash and draw perpendicular bisector to A double dash, A triple dash and B double dash, B triple dash. Again, I may get some point like this. I may call this point as I3. Like this, we can locate number of intersection points like this, right? So this is the beginning, location and orientation in a small interval of time. This is the new location. In another small interval of time, link is here. In another small interval of time, link is here, right? So from instant to instant, location and orientation of link is changing. For every instant, you may draw perpendicular bisectors and those perpendicular bisectors may intersect at one point. Locate all these points as I1, I2, I3, I4, I5, like that, any number of I's you can locate in a cycle of operation. What are these all? I1, I2, I3. So this I1, I2, I3, I1, comma, I2, comma, I3 and so on, these points are referred as instantaneous centers. Instantaneous centers are instant centers. Instant centers are virtual centers. Virtual centers are pole centers. Pole centers, right? Just copy this diagram, right? So I1, I2, I3 and so on. Like this, you can locate any number of I's in a cycle of operation. Okay? So all these points are referred as instantaneous centers or instant centers or virtual centers or pole centers. Okay? Just copy, I will give a little explanation on significance of this instantaneous center. So maybe I am blocking you. So first copy this diagram, then you write what is I1, I2, I3, I4 and so on. So I1, I2, I3, instantaneous centers or instant centers or virtual centers or pole centers. Any number of I's you can locate in a cycle of operation. I hope you copied this. Right now, let us try to understand what is significance of this instantaneous center. Actually, this link is carrying two different motions. It is executing translation. It is displacing towards right. At the same time, it is also rotating. So it is having two motions simultaneously, rotation as well as translation. But about this special point, at this instant, the link shall have pure rotation. Actually, link is carrying two motions, but about this special point, the link shall have pure rotation, no translation, man. At this instant, about this point, link may have pure rotation. At this instant, about this point, link may have pure rotation. At this instant, the link may have pure rotation about I3 and so on. Okay? So about instantaneous center, a link may execute pure rotation, but originally it may carry two motions. Dealing two motions is easier, one motion is easy. If you deal this link about I1 or I2 or I, you have to deal only one motion, man. That is rotation. If you take actual link in actual format, you have to deal two different motions. So by taking this concept of instantaneous center, we have to deal only one motion. That one motion is pure rotation. Okay? For instance, maybe C is another point on this link. C is another point on this link. I join A and I1. I join C and I1. And I join B and I1, right? B and I1. So what I told, man? So about I1, at this instant, this link may execute pure rotation. If anybody execute pure rotation, every point on that body will carry same angular velocity. If any body is executing pure rotation, the angular velocity of any point on that body will be same. Actual velocity may be different, linear velocity may be different, but angular velocity of each point of body which is executing pure rotation is same. So you can write like this, man. Omega is equal to VA by I1A. This is also equal to VB by I1B. This is also equal to VC by I1C. We know, man, tangential velocity or linear velocity is equal to R into omega. Radius into angular velocity gives you linear velocity. Angular velocity is equal to linear velocity by radial distance, right? So here, this point is carrying velocity of A, for example, velocity of A by radial distance, man. I1A is radial distance of A. So linear velocity by radial distance gives you angular velocity. Similarly, linear velocity of point B by radial distance. V is equal to R omega, or omega is equal to V by R. Linear velocity by radial distance, man. So since this entire link is executing pure rotation, every point on that link should carry same angular velocity. That's what I am writing here, right? Omega is equal to VA by I1A, that is also equal to VB by I1B, that is also equal to VC by I1C. Okay? Right. Now what I am doing is, I am joining this I1, I2, I3, right, and so on. I join all the instantaneous centers in a cycle of operation. Sometimes we may get straight line, sometimes we may get a curve like this, sometimes we may get circular arc, sometimes elliptical arc. It all depends upon how this link is moving. Okay? So I joined all the instantaneous centers from beginning to end in a cycle of operation, and this curve is called space centroid, right? This is called space centroid. Write down, man, one side heading, space centroid. Space centroid, space centroid, space centroid. It is locus of instantaneous center. It is locus of instantaneous center. It is locus of instantaneous center in a cycle of operation. In a cycle of operation. So join all the instantaneous centers from beginning to end. So whatever thing you get, whatever entity you get, that entity is called space centroid, right? Space centroid. I am going to define another centroid, man. Next you may write body centroid. Next you may write body centroid. B-O-D-Y, body. Body centroid. Body centroid. Write down definition, then I will explain. It is the path traced by, path traced by, P-A-T-H, path. It is path traced by instantaneous center. It is path traced by instantaneous center, which is attached to body, in a cycle of operation. In a cycle of operation. In a cycle of operation. So what I do is, I join first instantaneous center to link like this, man, right? I join I1 to body. This is kinematic link. So I join first instantaneous center to kinematic link by using a rod like this, man, here. By using a rod, I am welding this rod to link, man. This is kinematic link. AB is kinematic link. This is not kinematic link. By using a rod, I am joining A and I1. A and I1. So I1 is attached to kinematic link now. As kinematic link executes motion, this rod also will move, and along with this rod, end point of rod also will move. For instance, I attach one pen here. At the end of this rod, I will attach one pen or pencil. Then give motion to link. As this link is moving, this rod also moves. As this rod is moving, this pen also will move. That pen will draw a curve. Some entity it will draw depending upon type of motion. That entity is called body centroid. Path traced by IC, which is attached to body, is called body centroid. Space centroid is different. Body centroid is different. What is space centroid? It is the entity which is drawn through all instantaneous centers. What is body centroid? It is path traced by instantaneous center which is attached to kinematic link or body. So this is the difference between body centroid and space centroid. Write down, man. Write down one more point. Body centroid and space centroid. Body centroid and space centroid. Body centroid or space centroid roll about each other. Roll about each other. Roll about each other. And this concept is used. And this concept is used. And this concept is used in the manufacturing of a pair of elliptical gears. A pair of elliptical gears. A pair of elliptical gears. Pair of elliptical gears. Right. One more I want to define. Write down next. Instantaneous axis. Instantaneous axis. Instantaneous axis. Instantaneous axis. Write down what is definition. It is line which is passing through IC. It is the line which is passing through IC, and normal to operation of link, and normal to plane of operation of kinematic link. Normal to plane of operation of kinematic link. Plane of operation of kinematic link. Okay. So here this link is moving on this board. So you can imagine this board is plane of operation of kinematic links, right? This link is attached to, board man, right? It is moving, it is executing various motions only on this plane. So plane of operation of kinematic link means board. So instantaneous axis is, it is a line, man, right, which is passing through instantaneous center, and normal to plane of operation of link. Normal means perpendicular to plane. My pen shows instantaneous axis. It is line passing through instantaneous center and normal to plane of operation. Here normal to plane of operation means normal to both. So this line is called instantaneous axis. Okay. Next you may write axode. A-X-O-D-E, axode. 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 Write down what is axode. It is the area traced by. It is the area traced by. It is the area traced by instantaneous axis. Instantaneous axis in a cycle of operation. In a cycle of operation. In a cycle of operation. At the beginning, instantaneous axis will be here. As instantaneous center moves, instantaneous axis also moves. It is not fixed, man. Now instantaneous axis here. Next instant, instantaneous axis will be here. So instantaneous axis moves along space centroid. When you move a straight line, this straight line will trace some area. A straight line is there here. If I move the straight line along horizontal plane, along straight line, the straight line will trace one area, man. What kind of area? Rectangular area. right? As this line is moving along this space centroid, this line will trace some area. That area is called axode. That area is called axode. So this is regarding instantaneous center of a single kinematic link. So in this entire discussion, one point is important. A kinematic link is having two different motions, rotation and translation. But about a special point which is called instantaneous center, the link may have only one motion. That one motion is pure rotation. And dealing pure rotation is easier than dealing two different motions. That is advantage of instantaneous center. But in our mechanisms, you know, instantaneous center of single kinematic link is not so important. Rather, we have to define instantaneous center of a pair of kinematic links. In a pair of kinematic links, relative motions will take place, right? So pair of kinematic links are important than a single kinematic link. So now I am going to define what is instantaneous center of a pair of kinematic links. All of you may write IC of, don't write instantaneous center always, man. Instead you may write IC. IC means instantaneous center. IC of a pair of kinematic links. IC of a pair of kinematic links. IC of a pair of kinematic links. So first I define, then I will explain. First I define, then I will explain, right? Write down definition. It is the point about which, it is the point about which relative velocity of two links is 0. Relative velocity of two links is 0, or absolute velocity is same. Or absolute velocity is same. Or absolute velocity is same. I repeat, it is the point about which relative velocity of two links is 0, or absolute velocity is same. When velocities are same, relative velocity will become 0, man. Okay? So about instantaneous center, two links will have 0 relative velocity or same absolute velocity. That is the definition of instantaneous center of two kinematic links. Okay? So in coming few minutes, you know, I'm going to teach what are the properties of instantaneous center and how to locate instantaneous center. What are properties and how to locate instantaneous centers? You may put one side heading here, properties and location of instantaneous center. Properties and location of IC. Properties and location of IC. Location of IC. First point by point you may write. First point, about IC, the two links, about IC, the two links shall have 0 relative velocity, 0 relative velocity, 0 relative velocity, or same absolute velocity, or same absolute velocity, same absolute velocity. This is first point. Second point, for every pair of kinematic links, there shall be one IC. There shall be one IC. Next point. If mechanism carries n number of links, if mechanism carries n number of links, comma, NC2 actually, NC2 number of pairs could be formed. NC2 number of pairs could be formed. If any mechanism carries n number of links, in that mechanism, NC2 number of pairs you can form. So what is this NC2? If you expand this NC2, you will get n into n minus 1 by 2. So number of instantaneous centers in a mechanism is equal to what? N into n minus 1 by 2. This is very important formula, man, right? In many gate exams, they would give number of links and simply they ask, what is number of instantaneous centers? Okay, write down next line. Number of instantaneous centers in a mechanism. Number of instantaneous centers in a mechanism having n number of links, equal to n into n minus 1 by 2. N into n minus 1 by 2. N into n minus 1 by 2. This is very important formula. You know, in beginning classes I told, man, there are 6 to 8 very important formulae. Many gate questions are coming on those 6 to 8 important formulae. So this formula is one of them. At the end of theory emissions, I give conclusion, man, right? You know, at the end of all the sessions of theory emissions, during last session, I will indicate which formulae are important. What are those 6 to 8 important formulae? Okay? So n into n minus 1 by 2. This is very important formula. Sometimes, you know, while attempting competitive exams, generally we will be under little tension. When you are under tension, you would get silly doubts. When your brain operates under tension, you start getting silly doubts, right? What doubts? You memorize this formula, man. Number of ICs in a mechanism is n into n minus 1 by 2. When you are working under tension, your brain may say, is it n into n minus 1 by 2 or n into n plus 1 by 2? In our BTech exams also, sometimes you might get this kind of silly doubts, man. Is it n into n plus 1 by 2 or n into n minus 1 by 2? When you get this kind of doubts, you can easily rectify this doubt, man. For example, there are 3 bodies, man, right? There are 3 bodies. With 3 bodies, how many pairs you can form? You can form 1, 2. You can form 1, 3. You can form 2, 3. 3 pairs you can form. Put n is equal to 3 in this expression, man. If you put n is equal to 3, 3 minus 1, 2, 2 will cancel. You're getting 3 here. If it is n into n plus 1 by 2, how much you get, man? n is 3. If it is plus 3 plus 1, 4, 4 by 2, 2 into 3, 6. If it is n into n plus 1 by 2, you will get 6, man. Can you get 6 pairs from 3 bodies? You cannot get. From 3 bodies, you can make only 3 pairs, not 6 pairs. So definitely it is n into n minus 1 by 2. It is not n into n plus 1 by 2. When you get this kind of silly doubts, don't get tension, don't get panic. Use simple logic like this, man. Even you can use n is equal to, man. For example, 2 bodies are there. How many pairs you can form? Only 1 pair. Put n is equal to here. 2 minus 1, 1. 2 by 2, 2. So you are getting 1 only. Right? So it is n into n minus 1 by 2. Right. Next property, location of IC. Location of IC is function of geometry of mechanism, but not speed or acceleration. Next property. This property is important, man. Right? You may put 1 star rating for this property, right? Write down. For 3 kinematic links, there shall be 3 ICs. Just now we have seen. With 3 bodies, you can form 3 pairs, right? For 3 kinematic links, there shall be 3 ICs. 3 ICs, and all these ICs lie on, L-I-E, lie on same straight line. Lie on same straight line. Lie on same straight line. So this is called Kennedy's theorem, man, right? Many of you may know this. This theorem is called Kennedy's theorem. Kennedy's theorem says for 3 bodies, 3 ICs will be there. All those 3 ICs always lie on same straight line. Okay? Never forget this, man. In many problems, we can use Kennedy's theorem. For 3 bodies, 3 ICs will be there. All 3 ICs should lie on same straight line. Next property. Next property. IC may lie at joints. IC may lie at joints or on links or ORR out of links. Sometimes IC may lie at joint of 2 links. Sometimes IC may lie on link somewhere. Sometimes IC may lie out of links, man. Anywhere it may lie. It may lie at joint, it may lie on link, or it may lie out of links, like that, man. Next property. More than one IC can lie. More than one IC can lie at same point. More than one IC can lie at same point. 2-3 ICs may present. When you get 2-3 ICs at same point, don't get tension, man. It is possible. At same point, you can have number of ICs. Okay? Now, let us concentrate on location, man, right? How to locate ICs, right? Write down next point. When 2 links are joined by pin joint, their common IC lies at center of pin. Their common IC lies at center of pin. For instance, this is first link, this is second link, this is third link, and this is fourth link. Okay? And in this mechanism, all joints are pin joints only, right? At this joint, 2 links are joined. Link 1 and link 2 are joined by this pin joint. So at center of this pin joint, their common IC lies. I1 2 means instantaneous center of link 1 and link 2. Got my point? When 2 links are joined by pin joint, their common IC lies at center of pin. At this pin joint also one more IC. Which IC? At this pin joint, link 2, link 3 are joined. So definitely I23 lies here, man. Similarly here, I34 lies. Similarly at this pin joint, I14 lies. So if 2 links are joined by pin joint, their common IC lies at center of pin. Okay, right. Next point. When 2 links have pure rolling motion, or you may write in this fashion, when 2 links execute pure rolling motion, their common IC lies at point of contact. Okay, here 2 rollers are there, right? These 2 bodies are executing pure rolling motion, man, right? This is body 1, this is body 2. They are executing pure rolling motion, man. You know, what is the motion between a pair of gears? Theoretically, it is rolling. Theoretically, we assume motion between 2 gears is pure rolling. Maybe these are 2 gears, man. 2 gears. Where their IC lies? When 2 bodies are having pure rolling motion, their common IC lies at point of contact, man. Here, IC lies. Previous IES question. Similarly, here, A plane surface is there. On this plane surface, a roller is executing pure rolling motion, man. Roller is executing pure rolling motion. This is first body, roller is second body. With respect to first body, second body is executing pure rolling motion. What is relative motion between these two? Rolling motion. Body 2 is executing rolling motion, pure rolling motion with respect to body 1. So where their common isolate? This is particularly very important bit, man, right? Many times this bit came in gate exam. It is 5-star bit, very important bit. They give this diagram and they will ask you where their IC lies. Center of disk, here, here or somewhere. Like that they give 4 locations, man. Where their common IC lies, since they are executing pure rolling motion, their common IC lies at point of contact. Here their IC lies. Okay? So whenever two bodies are having pure rolling motion, their common IC always lies at point of contact. So if you want to copy, you can copy, right? So this is regarding pin joints. When two bodies are connected with pin joint, their IC lies at center of pin. When two bodies are having pure rolling motion, their IC lies at point of contact. Roughly you copy, right? Don't take much time. First you copy this, then you may copy this. Similarly, a curved surface is there. On this curved surface, a disk is rolling. A disk is executing pure rolling motion, right? So this disk is executing pure rolling motion on this curved body, right? This is first body and this is second body. Their common IC also lies at point of contact. And another curved surface is there, maybe like this, man, right? Concave surface. And here internally a disk is rolling, a disk is executing pure rolling motion. Maybe this is first body, this disk is second body. Their IC also lies at point of contact. Their IC also lies at point of contact. In all these diagrams, rolling, 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 pure rolling, pure rolling, pure rolling, right? Without any sliding or slip. Without any sliding or slip. I hope you copied these diagrams, right? Now next, a plane, okay, I dictate, then I explain by using diagrams, right? Write down next. When two bodies are executing, pure sliding motion, their common IC lies at center of curvature on common normal, center of curvature on common normal. So now we try to understand. A curved surface is there like this. On this curved surface, a body is executing pure sliding motion, right? This body is executing pure sliding motion, right? This is first body and this is second body. where their IC lies. Their IC lies on common normal. This is common normal. This is normal to both the bodies. Okay. The IC lies on common normal at center of curvature. Maybe this is center of curvature, man, right? Generally, we indicate center of curvature with O, right? And this is what, man? Radius of curvature. When two bodies are executing pure sliding motion, their common IC lies at center of curvature, like this. Now, I will take another example. A plane surface is there. A plane surface is there. On this plane surface, a body is executing pure sliding motion. This is first body and this is second body. Here also relative motion between these two bodies is pure sliding. Where the IC lies? The IC lies on common normal at center of curvature. Where center of curvature lies? What is radius of curvature of this plane surface? Radius of curvature of plane surface is infinity. The center of curvature of this plane surface lies at infinity. Why? Because R becomes infinity. So I can easily say instantaneous center lies at infinity on this common normal. Okay? It is simply because radius of curvature of plane surface is infinity. Center lies at infinity. Okay? So first copy this, then copy that, then explain further. Right. So copy this also, man, right? In mechanisms, many sliding pairs would be there. Wherever sliding pair is there, their common IC lies at infinity, right? Okay, now another example here. A plane surface is there. A plane surface is there. On this plane surface, a disc is placed. A disc is placed. This is first body and this is second body. And this disc is executing pure sliding motion, man. This disc is not rolling. Rather it is sliding. Generally when we apply brakes, the tire tends to slide over road. In normal operation, the motion between road and tire is pure rolling. When you apply brakes, the motion may become little sliding, right? So here this disc is executing pure sliding motion, man. No rolling whatsoever, only sliding. Then where their common IC lies? Center of disc, point of contact, or at infinity? Simple, man. The motion between these two bodies is pure sliding. Definitely instantaneous center of these two bodies lies at infinity on common normal. On common normal. Okay? It all depends upon relative motion. What kind of relative motion is presenting between two bodies, right? Pure rolling, point of contact, man, right? Pure sliding, the instantaneous center may lie at infinity. Just copy this. I hope you copied. Now next, again disk is there, and the disk is turning because of torque. The disk is turning about its center because of torque, and this disk is not moving towards right, man. It is only turning here only. It is not moving rightward. Maybe this disk is connected to a shaft like this. Okay. This is center of shaft or center of disk. And because of torque, this disk is rotating or turning about this point without translation. It is not moving anywhere. At same place, same point, it is turning. Where IC lies. If disk is turning by torque without translation, where IC lies? Point of contact or point at infinity. So in this case, instantaneous center lies at center of disk. Instantaneous center lies at center of disk. Again I am saying, man, this disk is turning without any translation. Because of what? Turning moment or torque. You are applying torque on this disk. Because of torque it is turning, and it is not translating towards right. It is not translating towards right. Okay. So their IC lies at center of disk, man. Center of disk. Please copy. Right. Next, the disk is sliding and rolling. Here the disk is sliding, at the same time it is rolling. Sliding motion is there, rolling motion is there. It is rolling, at the same time it is sliding. Then where their IC lies? Pure rolling, point of contact. Pure sliding, point at infinity. If this disk is rotated by torque, center of disk. Now one more case on this disk, man. This disk is having sliding and rolling, and it is translating towards right also, man. It is rolling and sliding. Both motions are there where their common IC lies. Many faculty may say their common IC lies between point of contact and point at infinity, right? Some faculty may say for rolling IC is here, for sliding IC is here. So they may think for sliding and rolling IC may lie at center of disk. All these are wrongs. All these are wrongs. In this case, IC is not defined. For every complex motion, IC cannot be defined. IC is defined for simple motions. If the disk is executing sliding and rolling, both motions are there, I cannot define instantaneous center. I can say like this, man. If rolling is predominant, IC is close to point of contact. If sliding is predominant and rolling is negligible, IC may lie at infinity. If both are considerable, rolling is not negligible, sliding is not negligible, in that case, I cannot define instantaneous center. For every complex motion, IC is not defined. So beware of that, man, right? So with this, we end this session. In coming session, we are going to do velocity analysis by using instantaneous center method for 4-bar mechanism and other mechanisms. Until next session, have a great day. Thank you.